Hello students, welcome to my channel Positron. Today's topic is a dimensional analysis. Dear students, I made the two videos already. The first video was system of units and a fundamental quantity, derived quantity, and that is complementary quantity. The second video was based on the error analysis, calculation of error in different mathematical combinations. Third one, this is the third video based on dimensional analysis. What is the dimension and why do we study the dimensional analysis, and with the help of dimensional analysis how we can establish different formulas, how can check the validity of the formula. Dear students, name of my channel is a positron. It's interesting, you might ask that why the name is positron. You know the fundamental particle is about electron, proton, neutron. Similarly, positron is a fundamental particle. Every fundamental particle has their antiparticle. So, electron has the antiparticle positron. The mass of electron and positron is the same, but the charge is opposite in nature. Now, dear students, today's topic is a dimensional analysis. Now, question is that, what is said to be the dimensions? What are the dimensions? You know the fundamental quantities about. The first one is a length. Second one is a mass, time, electric current, then temperature, amount of substance, and last one is a luminous intensity. Dear students, you must know the length is represented by L, mass is capital M, time is by capital T, electric current by ampere A, temperature by Kelvin K, amount of substance is directly it's written mole, and third one is a luminous intensity is candela CD. Actually, sometimes we are a bit confused that these are the dimensions. Actually, these are not the dimensions. These are the representation of fundamental quantities, right? These are just the representation of fundamental quantity. This is length, mass, time, electric current by ampere A, temperature by Kelvin K, amount of substance mole, and luminous intensity candela. Now, dear students, question is that if MLT A theta K like this, these are the representation of fundamental quantities, then what is the dimension? You know, in my last video, I had discussed with you all that there are the three kind of quantities. One is a fundamental quantities. There are the 7 fundamental quantities. Just I have written on the whiteboard few moments before. Fundamental quantities they are the independent quantities like length, mass, time. If you are describing these quantities, no need to describe other quantities. Derived quantities are what? Derived quantities, those which are derived with the help of fundamental quantities, right? And third one is a complementary quantity. Complementary quantities are two. One is an angle and there is a solid angle. Unit of angle is a radian and unit of solid angle is a steradian. Now, dear students, what is very important that we have to discuss, just I have told you that there are the three kind of quantities: fundamental, then derived and complementary quantity. Dear students, there are the fundamental 7 and complementary 2. So, except of these 9 quantities, 7 fundamental, 2 complementary, except of these 9 quantities, all other quantities are derived quantities. So, what is the dimension? Dimensions are those powers which are raised on the fundamental quantities to represent derived quantities. Again, I am repeating that what is the dimension? Dimensions are those powers which are raised on fundamental quantities to represent derived quantity. For example, I am just considering a dimension here. Do not think about the explanation because just after that we are going to find many various dimensions. Like suppose force is represented as mlt minus 2. Like work, the dimension of work it is represented as ml square t minus 2. So mlt is a representation of mass, length and time. It is not the dimension at all. Then what is the dimension on this? These powers m in the force, the dimension of force is m to the power 1, l to the power 1, t to the power minus 2. These powers 1, 1 minus 2 are the dimension. They are the representing the dimension. And how do we call that? We say like this, that in the force, mass has the dimension 1, length has a dimension 1 and time has a dimension 2. In a similar way, in the work, the dimension of mass is 1, dimension of length is 2, dimension of time is minus 2. Now dear students, let's talk about the some dimensions. Some dimensions are like, first one is either velocity or speed, right? You know, velocity is a vector quantity, speed is a scalar quantity, but when you are considering dimension, there is no difference between the velocity and the speed. That is displacement upon time, and displacement is a L and time is a T, so it is a LT minus 1. If you come next to the acceleration is what? Acceleration is expressed as rate of change of velocity. Dear students, now the dimension would be what? Sometimes we got confused that if the dimension of velocity is LT minus 1, then what will be the dimension of change in velocity? That confuses us. But there is no question of confusion. There is no question of confusion. Actually, you represent the velocity in terms of meter per second. And change in velocity also you represent in terms of meter per second. So that whatever be the dimension of velocity, same will be the dimension of change in velocity. So the acceleration is the rate of change of velocity. So the dimension of acceleration becomes LT minus 1, representing the change in velocity, and just in denominator is a time. If you will bring here into numerator, it will turn into LT minus 2. Now dear student, this is the acceleration. Now move further. Work or energy. You know, work or energy, this is expressed in terms of joule. Work is equal to force into first we should find force. Now force how will you define? Newton's second law. F is equal to m into A. So the dimension of force becomes, mass has a dimension m and acceleration has a dimension LT minus 2. Work is a what? Work W is equal to F into S. Force into displacement. Now the dimension of work, very simply you can get mLT minus 2 into L, and that is equal to mL square T minus 2. Dear student, there is no need to mug up many of the dimensions, right? Many quantities you will study further, and when you do study something new quantity, at the very moment, at the same time, you should find the dimension of that. Now, but the few important dimensions we should discuss here, like this. Next one is a momentum. Momentum is what? P is equal to mv. So the dimension of P becomes, mass is a m, and velocity is a LT minus 1. So it turns out to be mLT minus 1. Like we can find angle. Angle equal to arc upon radius. Now you know, arc is also measured in terms of meter or centimeter. It is also in terms, and radius in meter or centimeter. So L by L. So it is, theta is a dimensionless quantity, right? A dimensionless quantity also can be written like this. Means in the dimension in angle, the dimension of mass L and T, the dimension of mass, length and time, all are the zero in angle, right? If you are considering the dimension of angle, then you will say that in the angle, dimension of mass, length and time is zero. Now, let's move further. Some very few important dimensions are from Newton's law of gravitation. You know that is gravitational constant. More often it is asked in the question paper that you know that Newton's law of gravitation is F equal to G m1 m2 upon r square. So G is equal to F into r square. R square I have brought here and m1 m2 bring here. So you will get like this. Now dear student, the dimension of G works out to be, the dimension of force is a what? That is a mLT minus 2 R. R has a dimension L, so R square has the dimension L square divided by m1 m2. Both are the masses, so it is m square. Now if you will bring here m square, that will turn out to be m to the power minus 1, L into L square, L raised to the power 3, T to the power minus 2. So in universal gravitational constant G, mass has the dimension minus 1, length has the dimension 3 and T has the dimension minus 2, right? In this way you can solve many of the dimensions, but some interesting dimensions you will study further, like just I have discussed with you all the linear momentum. There will be angular momentum, moment of inertia, right? Velocity you have got. Further we will discuss in next chapter when you will be studying motion in plane. Then we will discuss angular velocity, right? Actually, there are the I'm not going into deep. There is a linear motion and rotational motion, right? So as you study linear momentum, in linear motion, in rotational motion there will be angular momentum. In linear motion there will be mass. In rotational motion there will be moment of inertia. So the new quantities, when you will be aware of that, then at the same moment we will find out the dimension of that quantities. Now dear students, this was the few dimensions I have tried to find out at the board. We are studying the dimensional analysis. Now, first we find some dimensions of derived quantities. Now, the uses of dimensional analysis. What is the uses of dimensional analysis? What are the uses of dimensional analysis? First one is conversion from a system of unit to other. From a system of unit to other, right? This is actually the dimensional analysis has three basic uses. First one is conversion from a system of unit to other. Second one is to check the validity of a formula. And third one is to establish a formula. There are the three uses of dimensional analysis. Dear students, we are studying dimensional analysis, uses of dimensional analysis. There are the three basic uses of dimensional analysis. First use is that you can convert a physical quantity from one system of unit to other system of unit by just using dimensional analysis. Second one is to check the validity of a formula, that whether the given formula is dimensionally correct or not. And third one is if it is given that a particular quantity in experiment depends on the following quantities, then you can establish a relation between those quantities. This is also done by using dimension analysis. Now, dear students, let's study in brief the first one, just to convert a physical quantity from one system of unit to other system of unit. How we can do? The basic concept involved here is, let it is given 1 kilogram sugar. Sugar is not important for you, but 1 kilogram, this is means the sugar has been represented by two quantities, two things. There are the two steps. One is a 1 and another is this. This 1 is a numeral value and this is a unit. 1 kg. 1 is a numeral value and kg is the unit. And that can be written as a 1000 gram sugar. Right? Now, dear students, you know this kilogram is a unit of mass in MKS and this is gram is a unit of mass in CGS. 1 kilogram sugar is equal to 1000 gram sugar. You know well, right? 1 kilogram sugar is must equal to the 1000 gram sugar. And both are similar. 1 kilogram sugar and 1000 gram sugar is a similar. It means, it proves that a physical quantity is expressed by two things. First one is a numeral value and second one is a unit. Any physical quantity is represented by two things. One, the first one consists a numeral value and second one is a unit. And n into u equal to constant. Why? As you said that 1 kilogram sugar is equal to 1000 gram. Either you say 1 kilogram or you say 1000 gram. Means if you are converting the unit, then quantity does not change it. That is why n into u equal to constant, or you can say n1 u1 is equal to n2 u2, where n1 is a numeral value of that physical quantity in first system of unit and u1 is the first system of unit and n2 is a numeral value of that physical quantity in second system of unit and u2 is the unit in second system. Or you can write n2 is equal to ds where n2 becomes n1 u1 upon u2. Now, dear students, you also can write m2 is equal to n u1 upon u2. Now, look here. It is, I am writing like this, m1 upon m2 to the power a, l1 upon l2 to the power b, and t1 upon t2 to the power c. Dear students, let's try to understand again what I have said, that n into u. Numeral value and product of unit is also always constant. Similarly, the example I have given you all, that 1 kilogram sugar is must equal to the 1000 grams. Sometimes you say that 1 kilogram and sometimes you say 1000 grams. So, n into u equal to constant. In first system of unit, it is written as n1 u1. n1 is the numeral value and u1 is the unit in first system, and that is equal to n2 is the numeral value of that physical quantity and u2 is the unit in second system, and n2 is equal to n1 u1 upon u2. n1 I have written as it is, and now u1 upon u2 have been written as m1 upon m2 to the power a, l1 upon l2 to the power b, t1 upon t2 to the power c. Dear student, how does it come? Let's acknowledge it. Like force, the dimension of force you write mlt minus 2. Right? Then you will say in the force mass has the dimension 1, length has the dimension 1 and time has the dimension minus 2. Either it is in MKS or in CGS, these powers and these powers are the dimensions. Means these powers are not going to change. These dimensions are not going to change. Then what I have written here, m1, l1, t1 is the mass, length and time in first system of unit. m2, l2, t2 is the mass, length and time in the second system of unit. And but the dimension, when you move from one system of unit to other system of unit, power does not change, dimension does not change. That is why M1 upon M2 has a common power A, L1 upon L2 has a common power B, T1 upon T2 has a common power C. Now, dear students, at the same moment we can use this formula. That let the question is that you know the unit of 1 Newton is equal to how much? A dyne. You know, Newton is a unit of force in MCAS, whereas dyne is the unit of force in CGS. In similar way, work has the unit joule in MCAS and ERG in CGS. Now, question is that how many dynes are there in 1 Newton, right? Dear students, it is N1. Now let's solve. It is N1, it is U1, N2 is being asked to you, and it is U2. Now dear students, N2 is equal to the same formula. First, Newton is that what Newton is? Newton is the unit of force. So write down the unit of the dimension of force, that is MLT minus 2. Now, I have written here the dimension of force that works out to be MLT minus 2. Now, N2 is equal to N2, that we have to find out that how many dynes are there in 1 Newton. So N2 is equal to N2 equals to N1. N1 is a 1 into, that is Newton. We have to convert Newton into dyne, means MKS into CGS. And it means in first system of unit, M1, L1, T1 is in MKS, and in second system of unit, M2, L2 and T2 is in CGS. So M1 in MKS, that is 1 meter, M2 is a 1 centimeter. Now, this A is what? Now, compare it. This is M1, L1, T1 and M2, L2, T2 are representing the representation for the force. So A, B, C will be what? Compared with the dimension of force, A becomes in the dimension, in the force, mass has the dimension 1, so A is equal to 1. Here L has the dimension B and here L has the dimension 1, so B is equal to 1. And C, here time has the dimension C and here time has the dimension minus 2, so it is a minus 2. Now write down, so dimension of M, power A equals to 1, and now L1 is a 1 meter divided by 1 centimeter to the power 1, and both 1 second T1 and T2 whole to the power minus 2. This 1 into, this is 100 centimeter, either convert it into centimeter or convert it into meter. So 100 centimeter divided by 1 centimeter, that is 10 to power 2. This is sorry, it was a mass, sorry, it is kg and it is gram, I'm sorry. So 1 kg upon 1 gram, that is convert it into gram, you will get 1000 grams, so it is 10 to power 3. Now 1 meter, 1 centimeter, it will become 100 centimeter divided by 1 centimeter, 10 to the power 2, and power 1 is same, it will stay same here, remain same. Now 1 upon 1 is a 1. So you can write it is 1 to the power minus 2. 1 to the power minus 2 is what? 1 upon 1 square, and that is 1 upon 1 into 1, that is 1. So dear students, what you have got? N2 is equal to 10 to power 3, 10 to power 5. So 1 Newton, that works out to be 10 to power 5 dyne. Right? 1 Newton, that works out to be 10 to the power 5 dyne. Let's move further. Dear student, this time I am asking a reverse question to you. Reverse is what? That question is this. This time the problem is that how many joules are there in 1 arc? How many joules are there in 1 arc? Now question is that Arc and joule are the unit of which physical quantity? That is work. So first write down the dimension of work, that is W is equal to mL square T minus 2. Again I am repeating my same formula. N2 is equal to N1, M1 upon M2 to the power A, L1 upon L2 to the power B, T1 upon T2 to the power C. Right? M1 upon M2 to the power A, L1 upon L2 to the power B, T1 upon T2 to the power C. If you will compare with this, then A is equal to, here M has the dimension 1, B is equal to 2, L has the dimension 2, and time has the dimension minus 2, C is equal to minus 2. Now N2 is equal to, this is 1 arg you have to convert into joule. This is N1 is 1 arg. You have to convert the arg, means first system of unit is expressed in CGS, means M1, L1, T1 are the part of CGS. They are represented expressed in term of CGS, means it is a 1 gram divided by M2, L2, T2. You have to convert the CGS into MKS, arg into joule. So this is M2, L2, T2 are representing the representation of mass, length and time in MKS. So it is a 1 kg to the 1, L1 is a 1 centimeter upon 1 meter to the power, this is 2, and 1 second again divided by 1 second to the power minus 2. Now dear students, it is 1 upon 10 to power 3, 1000 gram. So 1 upon 10 to power 3, and this is power 1, so it will become 1 upon 10 to power 3 into 1 divided by 100 centimeter. It is 10 to power 2, but it is a square, so it will be 10 to power 4. And this is 1 by 1, again just I have told you that 1 to the power minus 2 is equal to 1 upon 1 square, that is 1 upon 1 equals to 1. So it is a 10 to power minus 7. Means you can say that 1 arg is equal to this is again, this is gram, this is centimeter, and this is a second, and this is a kilogram, this is a meter, this is second. So 1 gram upon 1 kilogram means 1 upon 10 to power 3 into 1 upon 100 is a square of 100 becomes 10 to power 4, 10 to power 7. If you will bring into the numerator, it will be 10 to power minus 7. It means 1 arg is equal to 10 to power minus 7 joule, or 1 joule equal to 10 to power 7 arg, right? Either you say 1 joule is equal to 10 to power 7 arg, or you say 1 arg is equal to 10 to power minus 7 joule. As in the previous question you have find that 1 Newton works out to be 10 to power 5 dyne. Now this was the first use of dimension analysis, that is to convert a physical quantity from one system of unit to other system of unit. The second application is to check the validity of a physical formula. To check the validity of a formula. Dear student, the concept is a very simple. If A plus B is equal to C plus D, then it means A, B, C, D all possess the same dimension, because you know the physical quantities of same dimension can be added or subtracted. The different dimensions the physical quantity with different dimensions cannot be added or subtracted. Yet they can be divided, they can be multiplied, but they cannot be added or subtracted. But similarly, you can just imagine that is it possible to add 1 kilogram with 1 hour? Is it possible to add 1 kilogram with 1 hour? Or is it possible to add 1 hour with 1 ampere current? No. Why? Because they are the physical quantities with different units, different dimensions. It means if A plus B is equal to C plus D, it means A, B, C, D should possess the same dimension, only then it can be added or subtracted. let's do some job. The three equations of motion you know. First one is a v is equal to u plus at. Now check whether it is true or not. U is a velocity. Initial or final does not mean. You express it by meter per second. So u, the dimension of u undoubtedly u and v both has the dimension lt minus 1 and a into t. Look here, acceleration is lt minus 2 and time is a t. So it turns out to be lt minus 1. So the dimension is same here. Second one is a ds s is equal to ut plus half at square. Now s has the dimension L, u into t, u is a what? Lt minus 1 and time is t. So it becomes again L. And in similar way, this 1 by 2 has not to work anything with the dimension. This is a drawback, loophole in the dimension analysis, that it do not consider the constants. So there is nothing we have to do with the half. So at square has the dimension. A has a lt minus 2 meter per second square. And t square has a t square. So again it turns out to be L. So all these has a dimension of s is equal to ut plus half at square. S is L, ut is L, half at square also L. It means dimensionally it is a correct. And third equation of motion is actually that you know v square is equal to u square plus 2as. V square is equal to u square. The dimension of v or u is lt minus 1. When you will take the square of it, that is L square t minus 2. Now dear student, again I am repeating my words. Nothing we have to do with the constants. So A into S, A has a LT minus 2, S has a L. So it turns out to be L square T minus 2. This is also true, right? It means all the three equations of motion. First one is a V is equal to U plus AT. Second one is a S equal to UT plus half AT square, V square equal to U square plus 2S. All are dimensionally correct. So they are the correct formulas. Now, there is another formula, fourth equation of motion. That is the distance traveled in tth second. Distance traveled in tth second. That is written as s suffix t is equal to u plus half a 2t minus 1. Dear students, the question is that what is the distance traveled in tth second? Let distance, a body travels from here and comes up to here. So it is distance traveled in 8 seconds. But if the question is that how much distance is traveled in the 8th second, and let at t equal to 7, body has been here, right? Then the distance traveled in 8 seconds means the distance traveled by the body between t equal to 0 to t equal to 8. But if it is asked that the distance traveled in 8th second, then it means the distance traveled between 7 and 8 seconds, right? So you can say what I have said, that distance traveled in th second is a distance traveled between 7 and 8 seconds, means it is a distance traveled in 1 second actually. And that is why s suffix t is actually a distance traveled in 1 second. If it is asked that distance traveled in th second, let at t equal to 0, body is here, at t equal to t, body is here, and at t equal to t minus 1, body is here. So the distance traveled in th second means after t minus 1 second and before t second, the distance traveled means it is a distance traveled in 1 second, and distance traveled in 1 second is what? That is a velocity or speed. So it is a speed actually. The dimension of s suffix t is a speed, that is lt minus 1, and that is the dimension of u. Interesting is here, you have to find out the dimension of half a 2t minus 1. I have said that nothing we have to work with. There is nothing we have to do with the constants when you are studying the dimensional analysis. The existence of constant is a loophole, drawback in the dimensional method, because we cannot find the values of those dimensions. So it becomes 1 by 2 is a just constant, take it out. So It is a 2t minus 1. 2 and 1 are the constants. Similarly, you have to consider here t. That is a is a lt minus 2 and time t is t. That is lt minus 1 again. It means all the three components s suffix t, u and half a 2t minus 1 has the same dimension. It means this is a fourth equation of motion, that distance traveled in th second, that is s suffix t is equal to u plus half a 2t minus 1, is dimensionally correct. So it is a correct formula. Now dear students, we are just studying the dimensional analysis and their applications. The two applications we discussed, I discussed with you all. First one is about that conversion of physical quantity from one system of unit to other system of unit. Second one was what? That is a to check the validity of a physical formula, whether it is right or wrong, right? Whether it is a valid or not based on the dimensional analysis. And third one is a what? Third one is a to establish a physical formula. How you can establish a formula using the dimensional analysis? Dear students, let time period of a simple pendulum is capital T. It is given that, just by example I am trying to let you understand that the time period of a simple pendulum depends on the length of the pendulum and acceleration due to gravity at that point, at that place. It is given that the time period of simple pendulum depends on the length and acceleration due to gravity, length of pendulum and acceleration due to gravity at that point. Dear students, we do not know that whether it is not given whether the time period of pendulum is directly proportional to L, inversely proportional to L, or of what power of L does it depends. We do not know whether it is T proportional to L square, L cube or L to the power minus 2. So what I am doing, let T is proportional to the L to the power A and G to the power B, because it is not given on which power of L and G T depends, right? Now what you have to do? Nothing, just you have to write down the dimensions of all the physical quantities appearing here. Time has a dimension T, right? Proportional to length has a dimension L to the power A. G is a acceleration due to gravity. Whether it is a normal acceleration or acceleration due to gravity, you represent by meter per second square. So it is a LT minus 2 to the power B. Now, dear students, it is T proportional. It is L to the power A and this is L to the power B and powers are added. T to the power minus 2B. Right? Dear student, look here. At LHS, it is comprising the T, but it does not have L. So compare the powers. You have to write here L. Despite L is absent, you can write L to the power 0. It means in the time period, in the dimension of time period, length has a dimension 0 and time has a dimension 1. And that is proportional to L to the power A plus B and T to the power minus 2B. Dear students, if you compare the power, L to the power of L is here A plus B and here is 0. So A plus B is equal to 0 or A is equal to minus B. And T has a power here minus 2B and T has a power 1. So B is equal to minus 1 by 2. If you will replace here, B is equal to minus 1 by 2. Right? So it is A is equal to plus 1 by 2. Now, your formula becomes T proportional to L to the power A. A is a 1 by 2 and G to the power B is a minus 1 by 2. You might write like this: L to the power 1 by 2 upon G to the power 1 by 2. You write L upon G have common power 1 by 2 or T is equal to a multiply. Just if you are removing the proportionality, you have to multiply a constant K L upon G Dear students, if you are using the dimensional analysis to establish a physical formula, then there is no need to know about the constant. But if you know the value of constant in particular relation, then you can put here. K is a constant. You know the time period of simple pendulum is expressed as a t is equal to 2 pi under root L upon G. So K is generally, in fact, it is 2 pi. So your formula becomes t is equal to 2 pi under root L upon G. 1 by 2 I have replaced with the square root. So t is equal to pi square root L upon G. Now dear students, this was my third video on channel Positron. I tried to let you understand, and I'm sure if you think that my videos are helpful to you, my videos are supporting your studies, then please and please, my personal request to you, request from deep and sincere of my heart, please and please share, comment and like my videos and put the bell icon so that you can be notified on my videos. Meet you in next video. Bye bye.